Welcome you all to yet another lesson on this performance series. This lesson is about landing performance, not very demanding, nevertheless interesting lesson. The dispatcher, before dispatching the aircraft, he has to ensure that the landing performance meets the landing distances required as stipulated in the legal books. Generally, the landing performance may not be very limiting, and it meets, if it were to meet other takeoff and en route requirements, then it will obviously meet landing requirements. But if there are some failures in between in the aircraft, some equipment which are not working, such as set of air brakes are not working or auto brake one side is not working, and if the aircraft were to be dispatched with that condition, there could be penalties, and then you may have to the dispatcher may have to check it thoroughly before undertaking the aircraft on dispatch. So that's where this becomes critical. And also, he has to cater for adverse external conditions such as contaminated runways. And before I continue with the lesson, I just want to clarify that the landing distance available is same as the takeoff run available. That is, the stopway is not taken into account while calculating the required landing distances for all landing performance. Okay, we just defined saying that landing distance available is equal to the takeoff run available as we had defined earlier. But what could be the modification we will see in this? There is something called the approach funnel. I want you to pay close attention to this diagram. You see the end of the threshold, end of the runway. That is the beginning portion where the aircraft will come in for a landing. 60 meters have been left out, and then uh, the portion laterally on either side 150 meters, totaling 300 meters. And from the 60 meters edge, uh, uh, angled line of 15 degrees on either side is drawn as shown in the diagram. This portion is called the approach funnel. Why we are trying to define this approach funnel? This is the area in which the aircraft is likely to make its approach, even if there was a minor deviation. It is assumed that the aircraft will not go out of this approach funnel, and then now we are trying to define some more conditions as to how to modify the uh, landing distances. Yeah, we defined the approach funnel for this reason. If there were any upstanding obstructions within the approach funnel, as you can see in this diagram, which we have drawn, uh, an obstruction in the approach funnel in that area which we had defined earlier, then a 2% tangential plane, 2% tangential plane is covering that plane, that line is drawn, and thereafter the threshold is further displaced by 60 meters. That's how you need to adjust the landing distance available and define a displaced threshold. In most runways, they would have already done. As you can see, it's a fixed measurement. It doesn't vary with the aircraft type or something. The beginning portion probably will be used for takeoff, and because those distances are critical for usage for takeoff. So therefore, this is how we will be displacing the landing threshold or displacing the touchdown point. So your landing distance available would be slightly be different from the takeoff run available. It will be less, obviously. Some definitions, there's no major explanation required. VLS, lowest selectable speed, is 1.23 VS1G of the actual configuration. VS1G, I want you all to recall that it is stalling speed at 1G condition. V approach is the aircraft speed during landing 50 feet above the runway surface. Flaps and slats are in landing configuration and gears, of course, are extended. V approach is at least limited by the VLS, and we usually have a wind correction that is applied. So V approach is always greater than or equal to VLS. VREF is very similar to V approach in some aircraft. It is used as the main reference speed. It is the speed which the pilot aims to achieve at a 50 feet above the threshold before commencing the maneuvers for the landing per se. Of course, there will be an increment. This is a fixed for the configuration, and there will be an increment in case of an engine failure, and there will be an increment in case of a wind speed or gusty conditions as defined in the flight manuals of that particular aircraft. Okay, the landing distance for the dry runway surface conditions. These are all actually demonstrated by the test pilot to the uh, uh, authorities. Uh, he would be demonstrating, and it is defined as the horizontal distance necessary to land and come to a complete stop from a point 50 feet above the landing surface, and must be determined for different conditions, and the graph must be drawn or the tables must be given and published in the flight manual and supplied to the operators, and the pilot will be frequently referring to them for his day-to-day operations. Of course, the airplane must be in landing configuration and the approach must be stabilized. That's what is the required condition. Okay, demonstration of landing performance, as I told you, it has to meet several other requirements. Uh, it has to be standard temperature, the landing configuration has to be correct. The stabilized approach at VLS or VMCL. VMCL is a minimum climb limit speed for the configuration for a manual landing. The nuances of manual landing and auto landing we will see towards the end of the lesson. No excessive vertical acceleration, and runway surface has to be reasonably dry, hard surface, and acceptable pressures on wheel braking system. And braking means other than wheel brake, spoilers, reversers are not considered for dry runway surface conditions. I want you to catch your attention on this particular aspect. In all other cases, these other braking means can be used for demonstration. Okay, having defined the various requirements, now I've just shown this pictorially. Now, aircraft has made a steady approach and configured in the landing configuration, that is the slats, flaps, and the gear, and crossed the threshold at 50 feet with a speed which is greater than or equal to 1.23 Vs, and carried out a reasonable touchdown, and aircraft came to a complete halt with v equal to 0. This is the actual landing distance, or at this point I want you to notice that I have specifically mentioned that it is for a manual landing. So we are going to see it further. Let me explain some more regarding this demonstration for certification purposes. Now, for all a dry runway, the actual landing distances are demonstrated. May not necessarily be for wet runways and other contaminated runways. No use of reversers is being considered for dry runway performance. For contaminated and icy runways, again, I'm sorry, this also has to be demonstrated. Except for wet runways, data has to be published. Whereas icy runways, the performance has to be demonstrated. Reverse thrust usage is permissible, considered. Also, influence of temperature is also considered. That means different temperatures are considered. As I told you, for wet runways, it is not possible to give demonstration probably. So they dispense with the requirement, and it's enough if you publish the data for wet runways. Winds correction, if there were headwinds, only 50% of the reported headwind conditions are to be considered, and if there were tailwinds reported, then you have to consider up to 150% of the tailwind component is to be considered. And of course, these are published as well. Braking means other than wheel brakes, spoilers, reverses, as I told you, uh, uh, is considered for demonstration purposes. Okay, let's get to some tricky portions. That is the landing distance required for auto landing. As I told you earlier, whatever we had defined is for manual landing. That is a very simple, straightforward case. But for auto landing, uh, the uh, the landing phase is divided into two portions. That is the airborne portion and the land portion. Now, the airborne portion is the what we are going to discuss it first. Now, pay attention to this diagram very carefully. DA is what is being denoted by the airborne phase of the auto land. Now, the aircraft arrives at 50 feet above the threshold with the configuration and speeds as defined earlier. Of course, now aircraft, the autopilot is flying the aircraft, and once it crosses 50 feet, as it approaches the ground, there is a point called glide slope origin, and where it commences the flare maneuver. The autopilot commences the flare maneuver and then touches down. And of course, there is a mean touchdown point. The distance from the glide slope origin to the mean touchdown point is called D2. And of course, from 50 feet to glide slope origin point is called D1. These are all small distances, nevertheless. But the next, now to this D2 is added another increment, that is the 3 times the standard deviation of D2. Standard deviation is a statistical technique which is used to find out how much it deviates from an average. We will not go into the detail, but it provides a safe margin to the distances measured. These are all simulated over thousands and thousands of landings in a simulator, not in a physical simulator, but in a computer simulator. And then the average distances have been taken, and then we find out how much the deviation it takes, a maximum how much of deviation and the minimum how much deviation. and then we add an increment and arrive at this dA, which is equal to d1 plus d2 and 3 times standard deviation of d2. So this is the airborne phase or of the auto land. Get to the ground phase of the auto land. It is denoted by dg. It is calculated similar to that of a manual landing, except that there is a increment given to the v approach or v touchdown speed. V approach will lead to a touchdown speed. It is again 3 times standard deviation of the standard touchdown speed is added, and then the manual landing distance will be calculated, and the total distance arrived will be dA plus dg. Now, just understand that that increment is to the speed, because autopilot is flying it, and there is a possibility that there would be deviations in speed that the autopilot may not be able to fly that accurately. Okay, it's not only the landing distance required that needs to be satisfied for landing performance. If the aircraft were to abort a landing during an approach phase, or just immediately just before the touchdown, he has to abort a takeoff, abort a landing, and then go around. So the legal requirements specify the go around performance as well. We have something called approach climb. That means if the aircraft were to be on single engine, one engine inoperative, and the aircraft had to make a missed approach or go round from the approach. So the minimum climb gradient that needs to be achieved is 2.1%. Then, of course, the other conditions are one live engine thrust at toga, takeoff, go round thrust. The gear has to be retracted, and slat flaps in approach configuration, and 1.23 vs1g is less than the actual speed, which is less than 1.41 vs1g, and check that the v is greater than vmcl. vmcl is the minimum climb limit speed. It's called the minimum climb limit speed. That means the aircraft has to maintain a single engine. If it has to go around, execute a missed approach procedure, this is the minimum speed to which the aircraft can fly. That is called the minimum VMCL, minimum climb limit speed. The rest of it is all you are familiar, so we will not dwell too much. This is all simple definitions. Uh, but I want you to understand that the two conditions, the gear retracted and slat flaps in approach configuration. Therefore, the procedures of the airplane will define in such a way. If you have to go around in a with a one engine inoperative, then the call will by the captain will be to open the thrust and go around flaps. So the co-pilot has to retract the flaps to approach configuration if it has already been selected to landing configuration, and of course the gear would be immediately retracted on achieving a positive climb. So this is the immediate action that has to be achieved by the crew to uh, obtain this 2.1% climb gradient. If there was too much delay, maybe if there were obstructions, then maybe it could be critical. So I want you to pay attention to this aspect. Next is the landing climb requirement, which requires 3.2 uh, percent of climb gradient. It's simple bulk landing procedure that if the conditions are simple, both engines are operative, toga thrust is available after 8 seconds after moving the thrust lever. Remember, jet engines have got lot of lag in thrust picking up. So authorities have defined after 8 seconds that the thrust lever, and then it must uh, achieve this 3.2%. Of course, gear would be extended, and slat flaps will be in landing configuration, and the speeds as we have denoted 1.13 vs1g less than or equal to v less than or equal to 1.23 vs1g. So and of course v greater than or equal to vmcl. So that's these both the conditions have to be met. So as we explained earlier, these are all not very critical conditions. Provided the other conditions have been met, these are all naturally possible to meet, um, and normally it doesn't pose any dispatch problems. I hope you found the lesson interesting. Landing performance generally are not very critical, and of course, as I explained, if there were failures or equipment non-availability, limited dispatch, if the aircraft were under MEL for several systems, there are several adjustments that are possible uh, for landing distance, and that is a bit challenging, and they are interesting to learn as you go. In this lesson I have not covered it, and there is another lesson for landing performance which I will cover several other aspects of landing, the general conditions, etc. So please feel free to offer any of your comments, critical comments, on the email ID given below. Thank you.